Welcome back, everybody. It's time to start on Chapter 5 of Project Frankaru. Time to get into the steering. This is one of the two hardest parts of this build, which you will see later when I get into the tie rod ends. But for right now, the first thing is to get the steering rack mounted up on my bar that I installed earlier, my flat bar that it's going to bolt to. The steering rack used to originally bolt to the cross member where the motor mounts were that ran through this area. And the way they did that was on each side they used a saddle clamp that went around the rack and bolted up to that piece of sheet metal. The one on the right looks like this. It's basically round with a little rubber lining and a little saddle clamp that bolted in, and the other side is square, splits to go around, and has a little bit of rubber, and it bolted up on the driver's side. Well, I'm not going to use either one of these. If you've done anything with race cars, you know you usually replace the rubber with urethane, if that. In this case, since I'm making my own mounts, not going to use either one, straight aluminum. So the bar, this 1/4 inch by 2.5 flat bar that I used to bend to make the rack mount, is a little bit narrow, it turned out, where my bolts need to go, which is outside the pan. Because of that, I've added another piece of crossways bar here that is 1/8 inch thick by 1 inch wide, and it has the holes for mounting this too, and I just ran it across. This will get full welded later. And the rack then needs to get mounted up in here. Well, the first thing is I'm going to make a saddle mount for this side that has a round hole. So basically it starts out as a piece of billet aluminum, and I bore a hole in it. Then I drill 2 holes for my mounting straight up through, and then cut it in half to form a saddle. One of the important things to remember is that this rack is taller on this side. Even though it necks down, it steps down a little bit, and so this side has to be spaced off of that by 3/8 of an inch to keep the rack level. Okay, so that's what has to happen next. So through the magic of video, a piece of this has been turned into this. This, a 2-piece clamp, goes around the rack and bolts up there and holds the rack in place. So let me go ahead and get that up in there, get the rack kind of placed, and we'll talk about how it gets set up. A slightly more complex bit now. The rack is centered, right where it necks out here is centered up with the center of my engine and the center line of the car, so that makes it equal on both sides. Okay. Since I moved the rack forward and down, I have to lean it back a little bit. I want to make sure that the shaft for the steering input is pointing directly at the shaft at the firewall. So to do that, I had to rotate it back a little bit. And then I have to say, okay, that's why I want to lock it in. But if I just put a clamp on this like it had, it would try to rotate back on me. And so I have to make a spacer in here, a wedge, that sets that angle that the bottom of this flat here on the top side is then beveled, so it acts as a block, and when I lock it down it holds it in place. And to get that I used my little digital level to get the angle here, and it turns out that it's 8 degrees. So I've got an 8-degree difference. So I have to make a aluminum block, another little machining job, that goes on top of the rack that has that little angle on it. So that's next. Like that, we have a little wedge block made out of the same material, fits up in there, and it's going to sit on top like that. And I can't put it in from the back because the adapter plate is in the way, so I have to drop this down a little and squeeze it in there. So I don't know if I can just pull that down, maybe just enough. Yep, there we go. And I can get it in there, and now it's tight both sides here, and it's up against my bar. So that's holding that in position where it can't turn. So the next thing I have to make is another saddle clamp that goes around this and sits around this rectangle, but it has to have that 8-degree rotation in it. So, oh boy, that's a fun machining job. And that's going to take a little while. Not for you, for me. Hang up. So what was mere hours for me is seconds for you. There's the piece. So it's another billet piece. Had to cut it down so it can slide up and then back, and it has that 8-degree angle on it for the saddle to fit. So this slides up in here like that and clamps there, and that will hold that in place. So a couple of bolts and this should be in. Well, a few words about milling. So you can see the mess I've made. I got to do some vacuuming here. It's a lot of aluminum to make that bracket. But at the same time, you got to have some machinery, and that's what I keep saying about tools. And this is just an MSC mini mill. I've had bigger mills, big CNC, which I don't have anymore, but this does a lot of work for me. It doesn't even have a DRO on it. I've got to count the turns on the dials. They're graduated, but it's pretty accurate. I can get within a couple of thousandths. The big thing that I want to tell you, the big takeaway is buy a good vise. It doesn't matter as much about everything else as you've got to have good work holding. The tool, the vise, is the biggest thing here. The fact that it has a lot of mass to it dampens vibration, and you get those real pretty smooth cuts. And it makes life so much better when you don't have to fiddle around with something that's sloppy, loose, or doesn't hold well, or vibrates. A Kurt vise, ideal. Get one used, get one new, don't care. But get a good vise. They are invaluable in terms of turning out good parts. It's going to take care of a lot of your problems and fix them for you. So that's my 2 cents about milling machines. And you'll have to buy a lot of cutters. Trust me. You're never done buying cutters. So now I have to connect that steering shaft to the shaft up there. It gets very close to the exhaust. I may have to dimple it a little or just run it a little out and around, but that's going to have to get run between. And of course, originally it was just this little guy. Not very big and certainly way too short now. It's going to have to be lengthened a lot. So to do that, I'll have to cut it in the middle here and make an extension and weld it on both ends. When I weld it, I've got to be very careful. First, I want it straight so it doesn't wobble. So I got to figure out how to make that happen. Secondly, if I overheat that too much, these are not greasable. They feel great right now, but they're not greasable, and you'll just melt the seals and the grease out of them if you overheat them. So there's going to have to be some cooling going on while I'm welding it to keep that from happening. Another item that I didn't mention before is up here, where the shaft comes through, I needed clearance for the knuckle here, and this was sticking way up in the way. So this sheet metal, I cut it back to make clearance to get across there. I will plate that when I drop this out later, and I will close that all back up. But the thing is that it's all being supported now on this crossbar underneath. That's doing all the support. So with that being the strength, this isn't doing the work it used to up top. So I can get away with that, and that's not going to weaken anything. The strength is all down here, where this joint is pushing on that. So I'll plate that over, and this has to go in up top. So now I got to cut this, and then I will put both halves, one half here and one half up there, and measure the gap. That's how big I'm going to have to make my spacer then to fill in. So I'll use a piece of tubing and machine the inside. It doesn't have to be solid bar stock, because when it comes to torsional loads, just like a drive shaft, they're not solid. They're hollow for a reason. The torque on a rotational device in engineering, it's all carried on the surface of the tube at 45 degrees. So it always runs at a 45-degree angle on the surface. That's where your strength is. So diameter is a big item, not so much solid. It doesn't really help. So in this case, I'll probably use a piece of tubing, machine it out just to fit over this stub. I wish it was longer. If it were longer, what I would prefer to do is, even though I might weld it, I would drill a hole crossways through here and put a roll pin in there in case the weld was to crack for whatever reason. These are solid welded from the factory. Obviously it works. But if I had my choice, I'd put a pin in it. Unfortunately, I don't have my choice. So it's going to be cut this in half, make my tube, and then weld it up. And then I'll have to drop the rack down to get it in. But once it's in, that's it. Now we'll be able to move the steering rack from the steering wheel. Ideal. Then we get into all of this mess, and that's going to be very complicated. So let me get to cutting and measuring. Here we go. Okay, tacked on both ends. I was able to machine it tight enough that it was a press fit into there, so it's good and straight and square. I don't have to worry about it that way. Didn't make it sloppy. Something I forgot to bring up earlier. When you deal with drive shafts or anything like this that have U-joints, always make sure to phase them correctly. That is, you'll notice that the yokes, these two yokes line up and these two yokes line up. It can be that the two on the shaft are exactly the same or 90 degrees to each other. In the case of the way the factory did this one, it was 90 degrees, which is okay. Probably wouldn't matter, but I could go into a long description of the kinematics of how U-joints work, but your eyes would just glaze over and it wouldn't make much sense. So I'll just tell you, remember when you build a shaft, keep your phasing correct. So before you take it apart, mark it if you have to, and get them back in the same position. If you're about 45 off, it's the worst case scenario. You won't like the vibrations and you won't like all the awful things that are going to happen. So keep them straight. I'm going to bolt that in and go turn the steering wheel and congratulate myself. And then it'll be onto these tie rods. Catch you later. Take 2 handheld camera. Okay, with it all in, this is what it looks like. So I'll give you a look up to the steering column. There will probably be a steering doubler installed in here at some point. And coming on down to the rack and the brackets, and it's all installed and runs smooth as butter. Now, one thing that you may notice that I didn't mention is this bar. I'm going to be triangulating this back on both sides when I weld up this subframe to re-strengthen all of this and give it a lot more support side to side. It really could use it. So this is going to all be triangulated in and braced in when I weld all that up and put the plate up here. So all of that comes when I drop this out. In the meantime, got to move on. This is the point at which things become more difficult. The steering tie rods. So the deal was, this used to be way up here in the back, and since it's been dropped so much, my steering rack is now down here. The idea of just connecting the tie rod to the steering rack like that isn't going to work. The reason being the angles. So the lower control arm here sets one angle. The idea is that the tie rod should remain parallel to the lower control arm. That way, as it moves up and down, both of these swing in and out on an even parallel axis, and we don't get any bump steer. The front end doesn't move in and out. So right now, with it down here, as it would move up, this lower ball joint would be moving out, and since I'm already parallel here, as that comes up, it moves in. Therefore, as it moves up, this steering is going to try to turn in, and as it moves down, it's going to move out. Therefore, we have bump steer. That's no good. These have to move on a parallel axis to each other. One possible solution, which some people do, is to lower the outer tie rod end down here. So the amount that I'm below this joint, I'd have to be below that joint, which would put me right close to the dirt down here, and that's terrible. Furthermore, I'm inside the wheel. I'd be all the way down inside this tire in here, and I can't do that. If I was to bring it in and down, again, I would be shortening it, thus changing the length of these two and operating on different radiuses. And that's going to cause bump steer. Furthermore, you don't want this fragile tie rod down here getting in rocks and things. So it's best to keep this up top. So the solution of all of that is then I need to move this inner tie rod end back up where it belongs and connect this to this with a solid link. And that all sounds pretty easy, just put a bar. Well, no, I can't do that. The reason is this rack has teeth starting right here, and it moves in and out. When it moves in, it's all the way flush or just below flush on this, and these rack is totally exposed. You can't put a seal in the end of this because all this rack will be exposed, taking in dirt and just grinding it right into your steering rack and immediately jamming it up. The other thing is that with a boot on here, let me grab the boot. With a boot on here, when the boot it compresses, it can't go any further than that. Once it's this short, that's minimum, because then if I want to bring this all the way back to here, which would be steering all the way to the right, this would be crushed into nothing. I can't do that. So I have to extend this to allow my boot, so when it's all the way back, has this much compression. So I have to extend this first to get that. Then I have to go from there back up to where this is going to sit. So I need two pieces here. This is steel. I need that extension to be steel because it's going to take a lot of strength. So I need to make an extension up that's 3 inches long here to extend this out 3 inches so that when it's all the way in, I'm sitting about where I am right here. And that will give me enough for my boot to sit. So that's the next step, is to make those two guys up, and we're going to bolt into the end of this rack that's going to compress everything together and hold it together. So I'll get on that next. And after all the machining and such, here we have it. There's our extension. It connects back here to the rack and has a bolt through the middle. That is a 14mm bolt that will hold this all together with my Z-bracket. This had to be machined in a special way. On the end, there are two tabs right here. These interface with the slot in the end of this rack, keeping it from rotating. And that used to be used for this inner joint, but I need that because this has to not rotate. Out here on this end, I've got two flats. Those flats are going to index my steering bar that's going to come up through here. So in order for that not to rotate, I can't have that flipping back and forth. that has to be indexed, and this has to be indexed. And they're different than each other. It's there's a 30-degree slant back on these versus this. So by machining all of that, I now have something that'll work. And with this in here installed, now my boot can extend out, and when it goes in, it does not smash the boot. The next thing to do is to design up the Z bracket that's going to take this back up here. It's going to make that about 3-inch jog back is what we're needing, because that's how much I added. So that's next. Well, there it is. This is the next part to make, and it's going to make that Z bend back and up in order to catch this tie rod end back up here. So that is what I got to make next out of this. So as you can see, there's a lot to do. There's a lot of machining and a lot of material to remove. This is going to be pretty much a day's project making 2 of these. So off we go. I'll join you in, I don't know, about a day. A day later and a lot of aluminum shavings, I have a pair of these. And this is my little Z bracket that goes on the steering rack. Due to the fact that the inboard tie rod end is threaded into it up here, I wanted to have something better than aluminum threads. So I put a helicoil in here, 14mm helicoil. And this recess down here, as done earlier, interfaces with the flats on the shaft to prevent it from rotating, indexing it in place. And you may notice that everything is nice and rounded. A very important thing when you make parts: internal corners. Sharp internal corners will produce stress risers where cracks will start. Anytime you have a sharp corner internal, that's where crack begins. That's where it's going to propagate and break your part. On shafts, it's the same thing. You always notice there's a slight radius in there. The more gentle the radius, the better. You spread the load out on that corner, and that helps. External corners, it doesn't matter. I round them anyway for several reasons. Aesthetics, it looks so much nicer, and also because I like to keep my blood in me. And sharp corners will always find your knuckles, your hands, your forearms, and bleed you. So to prevent that, round them off. I use a carbide bit on a router, and a router table. You could use a file, a sanding belt, whatever. But it's much nicer to round them out. So this is how this goes together, and I'll show you what it looks like installed. And behold, there it is. So it's all connected up. Time will tell if this holds up to the beating that it's going to take. Don't just destroy the rack. The boot is in mid position right now. It'll get clamped here and here. All the fasteners are going to get Loctite and lock washers to hold everything in place, hopefully. And that, you'll notice that these lower control arm and this is parallel. We're at full droop right now. So these two are parallel, meaning we're in the right relationship to maintain our proper geometry and not get bump steer. So big deal. So this is what it looks like. It is it's pretty slick, so I hope it all works like intended. But it's a very strong piece of billet here. Should take a beating. And that's probably what it's going to get. So at this point, everything will be coming apart again. Once I get the rear tranny mount done, I believe that's next. And then all of this has to get taken out and full welded up, rebraced and everything else, and then back in and tightened up for real. So this is where we're at. But yay, it's looking great. That all fits. So next time around, I guess it'll be tranny mount, drive shaft, and shifter. Then we'll be done underneath here and everything can come out. So catch you on the next one.